Hello and welcome. Today I want to show you how it looks like when you get scammed on eBay. This is a Bitcoin mining board, or like in crypto mining board, where you can attach many graphics cards. And yes, I mine Bitcoin with graphics cards, sorry for that, but you get the gist of it. This is an H110 Pro BTC Plus. And why did I get scammed? Well, the owner told me that this board still boots up, but it crashes. And in the very first moment I opened up the package and looked at this board, I knew why. Let's show you. I know it's kinda hard to see in the reflection, but this is how our CPU socket looks like. Let's go together under the microscope and see why it is crashed. So now under the microscope, let's go over this bit by bit. You have this pin right here that is a little bit bent out of place. This wouldn't worry me too much. You have this pin right here that completely looks the other way. Let's bend this out of the way. You have this pin. I can already tell you I won't be putting in too much work for this board because this socket is awful. It will be a miracle if this board even ever boots. And this pin is almost about to break off. Okay, let's not touch that one anymore. Let's do this one also once more, getting it a little bit more into the direction where we need it. I'm going to be a little bit more rough with this board because, as you were already able to see, this board has very slim chance to ever boot or work again. So I'm not too worried about breaking something now. Let's go to the next position where I saw a pin which could be very bad, which is this one, which was completely folded on itself. Let's see if we can get you. I think this pin is also toast. And then you can also see this one in the top right. And its head snapped right off. This might be a little bit my fault as well because I'm very rough with them, but still. Yeah, there wasn't much holding that on anymore. Then let's see. We're going to leave this pin like that. Let me see. We have a pin here. Okay, still isn't good because the way it is bent is still not right, but let's keep it like that for now. There's a lot of pins. Oh, they might be fine. They look kind of out of place, but I think they might just pass. This one right here definitely does not pass. This one needs to go more to here. Let's leave it at that. Now we're going to get into the awful parts of this mainboard, because what we've seen before was the good parts, and now we see the ugly parts of it. Let's see now. This pin needs to go here. This pin, what happened to this one? Man. This is awful. Let's see. Yeah, I don't think this pin will ever make good contact again. Let's just make sure that it won't short out anything else. Just like this bad boy right here. And also this one. So let's move on. Having fixed, can't even say that with a straight face, fix those pins. Let's see. This is the other bad corner. Let's see. I don't think I've ever seen this much damage on something that wasn't like intentionally broken and where someone told me that this board boots. Because this is like there I've seen damage where like people drop a CPU in there or something like that or get stuck on something and like dislodged maybe 2 or 3 pins. But this socket has this damage in multiple corners of the socket. Yeah, I'm actually not too sure what to do about these pins because they're so bent out of place that I can't even get them as they were before. Because as you can see in the bottom corner, they are bent and I can't bend them back from there. Okay. Like I don't like this. Like how this pin is like still way too far to the right. But we're going to keep it at that for now. Because as I said, not much hope for the sport. There's the next pin that looks bad. Which is this one. Also not too much I think that we can do for this one. And that one up there. Compared to the other ones, these look very good. Compared to what we've seen so far. Okay. Um, this is the furthest I want to go right now. Like there's also some here. I think we've been here before. But let's keep it at this for what we've tried. Um, there's no more that I would say that are like directly touching different ones that they shouldn't. Um, most of them are awful, like these ones. I try to get them as much as I can into a position where they're supposed to be. And this corner is just awful. Like this is really bad. The way that some of these bend is like really bad. And I'm kind of scared to do this because it's probably not a good idea. but we're going to plug a CPU into this and put power into this, and we're just going to see what will happen. Um, I'm very well aware that putting a CPU into this might very well kill this CPU and lose me even more money. But we're going to try it anyway. This is a 6th gen processor. This is a Celeron. Probably the best thing to sacrifice, if to sacrifice anything. Let's get a stick of RAM into here. So we have everything built up. This might be one of the worst things I had so far to do on this channel, but let's see if it blows up in flames. Going to get our power supply onto here, and let's see. Yep, that's pretty bad. That is 500 milliamps of consumption. It actually starts up. This is very weird because we also have postcodes running and the power consumption doesn't look as bad. Let's see if we actually get a picture out of this, because this seems to try to boot up right now. And to the surprise of absolutely no one, this board does not display anything, even though my DDR tester actually goes to AF, which means boot, and it actually, if we reset it, but there's no sign of life on here. And I also have a keyboard attached to the USB, and we don't have any indication of life, so we don't get the numlock LED on the keyboard. But I have to say, this board got further than I expected it to get already. Let's check for some voltages. We have 1.8 volts here. This should be 2.5 volts, I think. This should be VPP. Oh, interesting. This is 0.4 volts. We might have to take a look at that. This should be 105 volts. Yes, this is the PCH. Then we have, what is here? We have 1.2 volts on there. Let's go on to DDR. We have 1.2 volts on DDR. Let's see. We have, I think this is supposed to be V core. Let's see here. Yep, 1 volt. So all of these look good. The only one that seems to be off is this one right here. 0.4 volts. There might actually be a chance for this board, weirdly enough. Let's see, this should be 3.3 volts. Yes, this is the 3.3 volts. So let's have a look what this is supposed to be, what I can find about this one, because I have a board view for this board. And let's see what this powers and if we have any problem that we can recognize there. And now we are back on our board view, and the inductor is this one right here, PL12. As you can see, it is a 3 VSB slot phase. So this goes to here, goes to half of the PCIe slots. And now if we go over to our overhead cam again, if we take our probes and measure this, we have almost 0 ohms. 2.5 ohms. My probes have very low resistance, almost 0. So we have a 2.5 ohms short on a 3 volt phase. We are going to try with voltage induction. We're going to put 3 volts into there. We're going to see if anything gets hot. And now something very interesting happened. I've now lifted the inductor from here and I've put on the output a wire, but as you can see, when I probe this place where I attach the wire to, you can see we have high resistance, like very high resistance. And if I go on its input, we see the short circuit that we've seen before. So this thing isn't shorted on its output, but on its input, which I didn't expect at all. To be very sure, I can show you the board view. I've attached it to the left side, and we saw that the left side has high resistance, and this side has the low resistance. The only thing on this side is this step-down converter. So what we probably need to do is we're going to desolder that step-down converter, see if our resistance goes up, and then we're going to supply our own 3 volts to it onto this pad, and we're going to see what happens. And right now you can see the controller. I've just injected some volts into there, 3 volts to be exact, into the actual output of it, so into there, and the thing got really hot. It got to like over 100 degrees within a second. So the problem with desoldering it is that we have a plastic connector for the battery right there. So what we are going to do is we're going to flood this thing with leaded solder on both of the sides, because there's no need to save this, because it is 100% dead. So let's use our big soldering tip, and let's just get a big blob of solder onto there, and we're going to do the same thing right here. And let's see, can we get it wet enough like this? No, I don't think we will. Okay, so what we're going to do is we're quickly going to run the hot air, even though we're probably going to melt the plastic connector, but don't really care too much about this board. So let's run our hot air. We have 400 degrees and 75% airflow. And our connector is already melting, as you can see. But we have the part removed. Only a little bit of the connector got melted. Don't really care about that because the functionality is still given. What we now need to do is we now need to clean up those pads. So we're going to be using some solder wick. And yes, I could be working with a lot more flux here, but the leaded solder should be enough. I just want these to not be bridged anymore. And just like that, let's clean up at least a little bit so you can assess the situation a little bit better. And as we can see now, our buck converter is removed. Let's now check for the resistance. We're going onto our overview again. And let's get a microscope out of the way. You can see my multimeter. And because it's the only component, there's not going to be a short here anymore. There's not going to be a measurement at all. And one thing I'm interested right now is, will this board actually work like this? So with this removed, because the thing is, we saw strange behavior in the power, and I saw on the board view that this thing is fed by 5 volts VSB. So something that is always running. So one of the standby voltages. So this might actually work without that power rail, because that power rail is for PCIe, I think, specifically. And we can check in the board view once more. Let's go into the board view. And this connects to a couple of places right here. This is ground, this is ground, these are resistors. These also these are feedback. Capacitors, I meant. These are capacitors because they're connected to ground also. And are these all also capacitors? These might be all capacitors also. This is some sort of signaling. But I think this all only going to the PCIe slot. So what we're going to do is we're going to use the integrated graphics of a CPU to see if this board actually will turn on without that power rail. So let's see that together. We get our power supply on here. Let me plug my DDR tester in here as well. Let's turn this on. This is 3 volts and we need 12. So this current consumption actually looks normal. Like 120 milliamps is more than I would expect for a board like this, where there's like no LEDs or anything. But it's still nothing where I would be highly suspicious of. So let's see now together. We turn this on. Let's connect also a display output to here. Let's also connect a keyboard. And the current consumption definitely looks different. We have way less current consumption than we had before. But I don't think we are posting. It's still stuck in the same loop as it was before. Let's check for some voltages again. But I think this time there won't be any problems anymore. We have 1.05. We have 1.8, which was this 2 volts. Shouldn't this be 2.5 volts? This might be still a problem. This is 2 volts. This might be VPP that is supposed to be 2.5 volts. We're going to check that if that is VPP and if we are on the right side of the inductor. This is 1.2 volts. This is also 1.2 volts, but this is for this controller, and the one that we had at the top was for DDR. Okay, well, the interesting thing is that on this inductor we had 1.8 volts before, and I thought that was correct, but this might be VPP where we need 2.5 volts. So let's go over to our board view once more. And let's get these out of the way. We are on our board view, and this was this inductor, and this is VPPM. This is supposed to be 2.5 volts, I'm pretty sure. Let's check at these outputs of this resistor right here, because I was checking here and it might be a little bit different of a voltage on this side. Let's go over to this view and let's see. We're going to turn it on again. We're still in voltage mode, and let's see on that resistor. Yeah, 2.5. So that's just probing from the wrong side of the inductor. So we have 2.5 volts on VPP. So this is right. And if we go on this side, we have 2 volts, but we have 2.5 on the output. So that is totally fine. Yeah, let's try to see what happens if we put 3.3 volts onto the output of this, if there's anything going to change then. And right now we have the board connected to our server power supply, as you can see in the top right here, and we have 3.3 volts on our on our lab bench power supply. We have one ground connected there, and then we're going to use this wire down here that is connected to the 3.3 volts, and let's connect this. This has no current draw so far, and let's start this up. Now we can't see the current draw anymore, sadly, of the board, because we're now using the power supply for injecting 3.3 volts, but there's no power consumption on this 3.3 volts, which is odd. So this is not even needed, I think. Should be good. And we still get no post. So this was not the problem for it, sadly. Let's try something different. Let's see if my connection is good. Yeah, as you can see, the connection is good. So 3.3 volts is not being utilized at all. The next thing I'm going to do is I'm going to flip the DDR slot, and we're going to see if that makes any difference. I cannot believe my eyes right now. How? How is this board posting? What the actual? I cannot believe that this board is turned on. And this is not a fluke. Um, I can show you it differently. Let's turn this off again. We've turned it off, and let's connect this power supply to it. So right now the board is off. The picture that you can see in the top right is just a frozen picture of what we had before. And now we're going to see the current consumption together. The 3.3 volts is not hooked up to this anymore. And let's turn this on. The current consumption looks pretty similar to what we had before. Well, now it's 1.8, it's less. And as you can see, we have a picture. We got into the BIOS. Let's go into the actual BIOS. But as you can see in the top right, we are in BIOS. And I can go around. This board turned on. How is this possible? How? You've seen the slot, you've seen the CPU socket. I can't believe that this is working. This is just ridiculous. And as you can see, this is the keyboard I'm using. It is actually on. Cannot believe my eyes right now. And I think some of the USB ports are dead because these USB ports didn't work. We're going to find out if Ethernet is going to work. Let's turn this off because I also don't have a heatsink on there. I'm going to put a CPU heatsink onto here. We're going to go into Windows together. And now I got everything plugged back in and got a heatsink on there. Let's see if it goes into Windows. The big thing that you need to understand here is this is a mining mainboard. This is specifically focused on just running a lot of PCIe. So if the CPU isn't going to give its full power, nobody cares. If only one of the two RAM slots is detected, nobody cares because this is a mining mainboard. The shorted buck converter that we saw, that is a problem because that is responsible for the PCIe slots. So we do have to fix that in order to make it work. But the only other thing that I think is important for this thing would be the the Ethernet to work, because that's the only thing that they would care about. So let's see now if this connects to Wi-Fi, because we're already in Windows, and as you can see, it looks like we are connected to not to Wi-Fi but to Ethernet. It's ridiculous. I cannot believe this is working. Let's connect the mouse onto here and let's run at least a single stress test for the CPU, because the CPU also needs to be stable for miners to care about it, because they want their rigs to run long term. Okay, let's see, these USB ports aren't working, I think. Yep, and now the keyboard is detected. We have Ethernet. It's working. As you can see, it's loading sites. I cannot believe this. I'm going to run a stress test. I'm going to run a single run of Linpack. This time not the big one, just a small one. So we're going to do a stress test, 2 gigs, 1 cycle. And I will see you again as soon as this will have finished. And I cannot believe it, but it passed. So the next thing we now need to do is to fix the 3.3 volts regulator. And you might not believe it, but I might have that part in stock. Let me check quickly. And now I found the part. This is an MP2143. I once upon a time bought a 5-pack of these, and there are still 2 left in there. Why do I have these? The interesting thing is, the very first mainboard that I fixed was an H110 Pro BTC Plus. This board, or this model of board, was the very first time I tried to repair a mainboard. And guess what also was blown up on that? Um, there was a lot more wrong with the very first mainboard I fixed, with the very first H110 BTC Pro Plus, but that thing still works to this day, and I've changed a lot of things on there. There was this regulator blown there, there was this chip blown, this regulator blown, and that regulator was blown. And also the face on the memory was blown. There was an awful power surge on that board, and a lot of things were killed on that board, but I still got that to work. And I probably will never forget the way I fixed that board, because back in the day I couldn't solder really well or anything, wasn't very confident in my fixing skills, and have never fixed an ATX mainboard before, and there were so many faults with this board that I thought I'm doing something wrong, but it worked out at the end for me, and that's why I still have components left over for this exact board. The other thing would be, I actually have a donor board, an H110 Pro BTC Pro Plus, that has a dead PCH. So I could have even taken that component from there. But we got lucky, and I actually have new ones. I think these are new. Let's prepare the place where we need to solder. We're going to add some flux right now. And now we have flux, and now let's add some leaded solder to these pads. And now we have leaded solder. And what we're going to do now is we're going to take out a component. So we now have the regulator laying right there. And what we need to do next is we need to find out where pin 1 is and where it's supposed to go. Pin 1 would be the one at the top left. And now let's go into the board view together and see. So pin 1 is in the top right corner, but I cannot tell you if that lines up with our buck converter. I'm not too sure how to place it in there, but we're going to use it like this, and we're going to place it in there, and we hope that it's going to be correct. I'm going to be soldering it by heating it up from the bottom, and so that we won't damage the battery connector anymore. And we're just going to hope that this is the right orientation, because there's no way for me to check, because there are no dots on the on this buck converter or anything. But I'm going to solder this on off screen, and we're going to see each other again when it's soldered on. And now the chip is soldered. Now I'm going to connect my probe, so we see the power consumption, and and it's dead. Ha! Yep, that wasn't right. That just started smoking. Well then. Let's check its resistance. And I think it just died. So, I think it might has to be the other way around. Let me quickly change that out for a different one, and we're going to see each other again then. And this time we've switched the orientation this way, and let's see if that is going to be right. I might leave it like this, because if it goes up and smokes and flames, you will able to see it like this. Let's get this better in spot so our power supply isn't in the way. Now you're going to be able to see the power supply also, and let's turn this on. And this is not connected. Let's connect our ground probe and see what will happen. 1, 2, and 3. And this looks very promising now. It didn't blow up, and I'm going to probe it quickly. And we have 3.3 volts that you can't see. Let's see. Let's go to, and now you can see my multimeter. And now we have 3.3 volts, as you can see. And I gotta say, I probably did that before already. Pretty sure I've killed one of those chips before like that also. Because there's a reason why I had 5 chips originally, and with fixing a single board, I only had 2 left. So I think this happened to me before, and I can very well see that happening to me. So, what we're now going to do is I'm going to spend quite some time building this up because I want to test with at least 3 or 4 graphics cards to see if this will recognize all of them. So we will see each other again when I have abundance of graphics card built up, and we're going to see if they are going to get detected or not. So this is the first time for me as well. As you can see, we have 2 graphics cards right here. This is a 760 Ti or something like that, and the Vega 64. We have the GT310, and we also have a Quadro 2000 plugged in right there. What we're now going to do is we're going to turn this on. We switch on the server power supply there. Now you can see some fans already spinning, some are not. And let's press the power button on here. It seems to be turning on. Now we are booting. And why I do this is we need to see if this recognizes multiple GPUs in these slots. Because that is what this thing is made for. And as you can see, we have picture. Let's now try to get into Windows. And then we're going to see how many of these cards are actually recognized. Windows is actually bad to recognize a lot of GPUs. I think 4 should be still fine, but you would want to use some sort of Linux for this. But let's see. So we do get an output from the GT310. That is that. Let's see if the Quadro, the Vega, and this NVIDIA card is being recognized. I'm going to switch the output on. Okay, I can. So as you can see, there's our Windows, and this is going to be quite tough because I have to now hold my capturing device with a single hand. And now let's go into our device manager, and let's see. We have 2 graphics card already detected in 2 more display adapters. So we have the Vega and the GT310. And now I'm going to wait. As you can see, there's some drivers probably installing for some of our video adapters. And right now, all 4 graphics cards are detected. Don't know why there is still an error, especially on the GT310, because we are displaying from that graphics card right now. But all 4 are recognized, and I think this board works the way it should be. I cannot believe that this board works. This has been such a roller coaster of a fix. I've never had that ever before on any mainboard. We had an absolute smashed CPU socket where I would never have thought that any CPU will even not get killed in there, but yet alone works. RAM is detected, we're booting up into Windows, it is stable, we have done stress tests to the CPU, and then we even had a buck converter that was shorted, a 3.3 volt buck converter, and then I even had the part on hand. I installed the part backwards, killed the part, and then installed a right one. And now we have this mainboard working. I think there's still some USB not working, but I don't care. Most of the mainboards don't need USB anyways, and some USB are working. We have multiple PCIe slots working, which is way more than we need. We have SATA working. NVMe probably works. I'm not going to test it now. But I'm just flabbergasted. I cannot tell you how impressed I am that this board works. I probably should never remove that CPU and that cooler just to be sure that it works like it is. But I hope you enjoyed the video. I hope you learned something in the process on this roller coaster of a fix. I hope you found it entertaining. Hit the thumbs up, hit the subscribe button. Thank you very much for watching. This was Mainboard Medic with an insane fix on an H110 BTC Pro Plus. Thank you all for watching. See you again. Bye.